Tonight we have a special visitor down from Brisbane. He is running a pretty substantial... Yeah, no, I didn't call you. I'll call you when I need you. So he's running a pretty, and obviously he's very enthusiastic. Can't wait to get going, but we're going to do some news before that. Thiago is down from Brisbane. He's running a pretty large project. I guess there's about 8 guys on the project. Is that right? And they're doing Angular, .NET Core. So then they're using containers for all their deployment, and he's going to be talking Azure, and Kubernetes. All right. What else are you going to talk about, Thiago?
Containers.
Containers. All right. Awesome. This is very cool tech. Thank you.
Thank you, sir. My talk is titled, Now I Have a Container. What now? So it's all about what you're going to do after you have the container, right? I don't know if you guys know, but 15% of the whole internet is run in containers nowadays. And considering this technology, it's such a new technology, you can get that evolving quite quickly. So it's something that you really want to get your head around. My name is Thiago Passos. I'm a solution architect at SSW. This is my Twitter handle, my blog, if you want to have a look. So we're going to talk about containers and what to do next. But before I get there, who here has a container already? OK. For those who don't have a container, who of you are .NET developer? .NET developer? Cool, cool. Awesome. So if you are a .NET developer, I'm going to show you in 4 quick slides how to get your first container, right? Before we get started, so we are on the same page. So if you have Visual Studio 2017 installed, you're going to find this little flag called Enable Docker Support, which is a very nice one. And once you do that, what you're going to have is this Docker file, right? The Docker file is just a definition of your image, which when you run, it's going to turn into a container, right? And with that, you can also run and debug your container, which is pretty cool. Where before you couldn't debug, or it was a pain in the ass to debug and things like that. So right now, Visual Studio 2017 makes it so much easier. OK, so once you do that, you're going to have your image, right? So if you go to your console and run Docker image, you're going to find your image in there. So now you have your image, now you have your container. Now we can get started. OK, so today we're going to talk about the life cycle of a containerized application. We're going to talk about what's the registry. We're going to touch briefly on the continuous integration story. And most of the talk is going to be around the orchestration. OK? Who here has heard about orchestration? Cool. All right. So the life cycle. So these are the basics of containerized application. So you have your dev environment. So this is the dev environment you're working on. So it can be a Linux, Mac OS, Windows, doesn't matter, especially if you're running .NET Core. You have your repository, your code repository, Git, yes, TFVC or whatever. And you have your Docker file in there. So just the one I just showed you. So you keep building your application. Once you're done, you create your image, and you push your image to a registry. On the other side, in the place you're going to deploy, you're going to pull the image, and you're going to run that image, right? As simple as that. OK, but what if you make a change to your container? So let's just take a step back here, and let's have a look at that screenshot that I had before. You can see here on the right-hand side, the images are fairly big, right? So 300 meg, that's one of the smallest images you can get for .NET Core. If you're running a Windows container, you're looking to several gigs instead of megs. So that's fairly big. So if you think every time I make a change, I'm going to push the whole image, that's going to be pretty expensive bandwidth-wise, right? But thanks God, that's not the way it works. So the way it works is you push the image the first time to a registry. If you've never pushed before, you're going to push the whole image. But any other time you push, it's just going to push the delta which is pretty awesome. So it basically slices the images in several parts, and it compares in a binary level the parts and only pushes the diff, which is pretty amazing. So that pushes to the registry, and on the other side, where you're deploying that application, you pull again only the diff and you deploy, and that's why the deployment is so quick as well. Okay. So here's an example of me trying to push an image that I already have in my registry. So if I do a Docker push in that image, what do you think is going to happen? That's an existing image. What's going to happen is all the layers are completely are the same. So you're going to see here that the layers are already there, so it didn't push anything. Okay. But if I try to push a new version, what's going to happen is most of the layers will be the same, and it just pushed a tiny bit, which is only your application, only the part that you changed. Is that cool? Okay, but what is the container registry? So the first time I heard about it, I thought somewhere that you put your image. It's pretty much it. So it's like a NuGet server that you install. It's just an application that you install. And its main responsibility is to distribute your image in a scalable and effective way. It also has some smarts to slice the image and compare in a binary level. Okay, but how do I push that image, right? So when I started playing with containers, I thought, all right, so there is a registry, there is a repository in the registry, and you want to push an image. So it's going to work the same way as a Git repository. That's what I thought, but it's slightly different. So first you have to do a Docker login in your registry. If you're using Docker Hub, which is the main registry for Docker, you don't need to put the URL at all. It's just Docker login, and then it's going to pop for the username and password. Otherwise, you just put your URL. That's a private registry, so it's going to prompt to enter the username and password, and I'm logged in. So it's going to cache the credentials. And after that, I can push emails to it. But that's not all. So what you need to do next is you have to tag your image with the URL. So that's the part that did my head. I didn't understand why you had to do that. Where in Git, you just set the remote repository, and you just can push multiple times. But with Docker, you have to tag every single version of your image. You have to tag again. So it's a bit painful if you're doing locally, but if you're using a build pipeline, that's all done for you. But basically, that's how it works. I tag the image that I have, the image web app. So I prefix with my URL of the registry and suffix with the version number. And then after that, that's it. That's all you have to do. And then you push the image to your registry. Then it's available, so you can pick up from anywhere else to push to deploy your image. Okay? The continuous integration. So the continuous integration doesn't change anything, and because of that, I don't have any slides for that, right? So the continuous integration is going to keep the same. You're going to build your application. You're going to test your application. All you need to do is change the way it's going to push your registry. Okay? So the previous slide is the way you're going to change your continuous integration. But also I'm going to touch the continuous integration in the orchestration story. But yeah, it doesn't change at all, which makes it easier to jump to containers. Okay, so the orchestration. Right, any pick for what orchestration is? No? Anyone have ever used? No? Docker Swarm. Cool. All right, so what an orchestration tool does for you. So why would you even think about using an orchestration tool? So here I'm going to cover some of the smarts and some of the beauty of an orchestration tool, and then you can tell me if you think it's valuable for you. Okay, first, and one of the most important parts is you have no server management, right? Especially if you're running in Azure, Google Cloud Service, AWS, or any of those, you can just spin up a cluster and off you go. You have all your servers there. You just say, hey, I need another VM, and it just spins up for you. You don't need to manage any of that, which is pretty cool. And that's how a cluster looks like. So this Kubernetes cluster, but all the clusters will work very similarly, right? So you have a master in the middle, which has all the smarts for your cluster, how to deploy, how to scale, how to self-heal, self-discovery, all this kind of stuff. And all the nodes around are just basically the workers. So they're just gonna run your containers. Okay, so the master is gonna tell, okay, so just run this instance here, and that's it. So they're just gonna run. So if you remove one, the master is gonna be responsible for redistributing the application somewhere else. Okay, self-discovery. So self-discovery for me was a bit, wow, so how does that work? Because it looks like magic. So in my mind was, all right, I'm gonna deploy an application, and it's gonna say, hey, I'm here, just use me. It sounded like magic to me, but it's actually quite simple. So here in the middle, it's the same topology. You have the master in the middle. I've got a deployment saying that I'm gonna deploy a few apps, okay, in here. And I've got two services, the service A and service B. So the service A will run any deployment that comes from the A, and service B will run any deployment, any application that's deployed by B. Does that make sense? Yeah, I don't think it does make sense. Now it's gonna make a little bit more sense, right? So in your master, you're gonna create selectors for your service. So like jQuery selectors, okay? So you have your service A and B in your master saying, okay, just pick up any application in my cluster that has this selector, app equals A, okay? So you can create the service before you even deploy your application. And when you deploy your application, you say, hey, that's my application A. And as soon as it's ready and available and it's running, the service will pick up and put under its load balance. Does that make sense? So every time you deploy a new version or whatever, it's gonna pick up that application that's running and available, and it's gonna put under that service. So that's how the self-discovery works. And that's gonna be used across all the other functionalities, which I'm gonna cover now. Okay, scaling. So scaling is something quite useful, and if you think about cloud, the first thing that comes to mind is scaling, right? So the ability to scale out as much as you need. So if you have 10 users today and 1,000 users tomorrow, you want to be able to scale up and down as you need. And scaling in an orchestration environment is quite easy. And that's how it works. So you have, again, your master in the middle, and you have your service with a single pod inside, with a single application. And all you're gonna do is, in your master, you're gonna say, hey, deployment, I want 4 replicas of this application. And how that's gonna work is, it's just gonna create pods, and the service is gonna take care of that. All you're gonna do is talk to the service, and the service is gonna handle any requests to the available pods. I'm gonna cover that in the demo as well. Okay, zero downtime deployment. So who here has 1 minute downtime when you're deploying? Nobody? 5 minutes? Half an hour? More than that? Or you just don't measure, you just go to production, change there, and that's it. Yeah, that's the cool thing about the orchestration. It is zero downtime deployment, which is pretty awesome, and that's how it works. You can actually apply this concept for any application without orchestration as well. So basically, what it does is it deploys your application one by one. So you have multiple instances, and you deploy your application. As soon as that's ready and it's warmed up, it's going to switch by node 1. So basically, that's how it works. So it creates the updated one, a new version, it creates a new IP address, and then it replaces as soon as it's available. And it does that one by one as soon until all the applications are up to date. There will be, at some point in the half second between the deployment, that you're gonna have some pods with one version and some pods with other versions. You can fix that by the service configuration if you want to. but most of the cases it doesn't matter. It's so quick that it doesn't even affect that. Okay, self-healing. Initially I thought self-healing would try to get your pod and fix that on the fly, right? But self-healing is about the health of your entire application, the application as a whole, right? So you have several instances of the application running. If one goes down, it's just gonna kill that instance and bring another one up. It's not gonna try to fix single instances. It's just gonna kill the instance and bring another one up, okay? And the same happens if a whole node of your cluster dies, right? For any reason. So if a VM goes down, whatever happens, if you're running updates in your VM and it becomes unavailable, that's what happens. So one node goes down, it will try to put the nodes somewhere else that's available, right? So the master is smart enough to do that, which is pretty cool. Okay, so now I'm sold. I'm going to start using orchestration tool, but which tool to use? There are so many around, okay? So these are just the top 5 that I found, all right? So you've got the Service Fabric, Kubernetes, Mesosphere, Docker Swarm, Cloud Foundry. So you've got plenty, okay? So which one to choose? It's hard to pick. But if I had no idea about Docker containers or orchestration, I would think that Docker Swarm would be the way to go, right? Because when you think, okay, Docker, container, they're pretty much the same word right now. So you think, all right, so Docker was the one who created the most well-known container. I would go for Docker Swarm, okay? So I'm sold. I'm gonna go for Docker Swarm. So the first thing I'm gonna do is I'm going to go to the official Docker website, and I'm going to find out how to get started. That's what everyone does, right? So I go there, and in the front page of the Docker website, they're offering Kubernetes. I thought, okay, that makes no sense. I thought, all right, so let's try Microsoft this time. So I'm gonna go to Microsoft and see what they're offering with the Service Fabric. And I go there, and they have this thing for a while now called Azure Container Services. And now they are slowly changing the name to AKS. So you can see that they're pushing Kubernetes more than anything else. So I've got even some internal knowledge that they are actually pushing to Kubernetes, and eventually, at some point, even the other container orchestrations will be discontinued. Okay, so finally, Kubernetes has won. So there is no doubt about it. Most of the users are the containers orchestrations are using Kubernetes, and that's it. I'm gonna go for it. And what does Kubernetes mean? So Kubernetes, it's a Greek word. I learned that yesterday from Adam's wife, which means governor, which makes complete sense. But anyway, I just called Kubernetes, and I didn't care learning the word. But yeah, that's interesting. Okay, so there are a few ways to create your cluster. I'm going to show you the very, very easy way. But if you want to go the hard way, that's all right as well. You can go for it. I just don't have time to go the hard way. But yeah, happy for you to go the hard way. All right, so I've got an Azure subscription, so I've got plenty of credits to spend on Azure, so I can go to Azure and create my cluster in there. And it's pretty easy, okay? So with the Azure command line, you can create your resource group, which is basically a group of resource in Azure, build together. So you can go there, create your resource group using the command line or the portal, and you just create your AKS instance. And that's it. You're done. So your cluster is created for you. Your whole cluster, all the VMs, all the connections, everything is done for you. Right? Now it's just a matter of creating and deploying your applications in there. Okay, so what you can do next is you can get the credentials locally the same way you would do a Docker login or Git login or any of that. So once you have the credentials locally, you can start using the kube control, which is the command line for Kubernetes. And that's just a sample command to get all the nodes in your cluster, including the master. But what you can do as well is you can do this AKS browse. So this creates a proxy locally pointing to your remote cluster that you can open the browser and start using the Kubernetes dashboard in your browser, which is pretty interesting. And that's how it looks like. I'm going to show that in the demo as well, but when you do that, it launches the browser with the proxy set up, which is pretty cool. You can do deployment here as well and manage your cluster here. But often you end up using more the command line. OK, you can do the hard way as well, as I said. Scott Hanselman wrote this blog post about building a Kubernetes cluster with a bunch of Raspberry Pis. So if you guys are a fan of Raspberry Pis, go for it. So he's got a bunch of Raspberry Pis. It might have been pretty hard. Haven't tried, so if you guys want to try it, just let me know. OK, so let's do a bit of demo. Have you guys have any questions? No? Cool. All right, so let me just close all this stuff that Adam opened. OK. All right. Just as an example here, I already got my credentials for the Kubernetes cluster. So I can come here and do a kube control get nodes. That's just an example of how it works. So it's gonna return me all the nodes in my cluster, including the master. So I've got a single node and a master. Simple. Here, what I can do as well, so let me stop that so I can show you. You can do a kube control proxy, which is the same as AKS browse, which is going to start that proxy. And now you can go to that URL and have a look at the dashboard, which is this one here. So let me go to the overview. OK, so that's the dashboard. I can do a bunch of stuff here, and I'm going to create some applications here so I can show you. So first thing I'm going to do is I'm going to create a brand new app with an existing container image. I'm going to use this one here. So who here ever had to create a PDF out of HTML for any of your clients? No? Yes? No? Yeah? All right, so that's something that we do all the time. So the clients want some report or something like that, and we need to generate a PDF. And that's a pain, right? I don't know if you guys had that, but I had that many times, and it's a pain to do that. So there is this container here that I found out that you can basically create this HTML to PDF as a service, which is pretty interesting. So I'm going to add one of those, and we're going to have a look later on. OK, so I'm going to paste the image. So that's in the Docker Hub. So this website here is the Docker Hub. So it's open for everyone for anyone to use. So I'm going to paste the container image here, and I'm going to expose that internally via the port 80. OK? So any application within my cluster that calls PDF, it's going to land on this application, right, through the port 80. So if you go from one application to the other calling HTTP column / PDF, that's where you're going to go. So that's how you talk to each other as well. OK, I'm going to deploy that. It's going to take some time to deploy. And while we do that, I will show you some other application that I created. So I created this app here a while ago now, which is a .NET Core 2.0 application, which is just an API, right? So it's a very vanilla API. As you can see, it's just a single controller in here, which returns a bunch of values, right? So seeding is awesome. Okay, and what I'm gonna do here is I'm gonna make a change to the application and see how that's gonna flow all the way to Kubernetes, okay, and to be available. Right now, if I go to my cluster, you can see that I've got some of them already deployed. So DDD Brisbane Dev. If I go to my deployments here, I can see that the latest version that is available there is 16. And I can go to my servers and go to the endpoint that exposed. And you can see that's working, right? So the application is there, it's deployed. I want to make a change and see how it flows all the way there. Okay, so I'm going to make a change here. Sydney is amazing. Cool. And I'm going to push that. Alright, so I've got that hooked to a GitHub repository that you can have a look later on if you want. And I'm going to push that. So now what I have is I've configured Circle CI. I don't know if you guys used Circle CI before. Anyone? So Circle CI is a free tool. So it's a build server for free that you can configure your build configuration, and it just builds everything for you. And the way you can configure, which is pretty interesting, is via this YAML file here. So these are all the steps that you have to do to build your application. So you can run tests, you can do a bunch of stuff here, okay? And what I'm doing is just building my application, creating the image and pushing to a repository, to a registry. Right. So after I committed the change, you can see that Circle CI picked up. So it's running. And I'm going to go now to my registry in Azure. So my private registry is in Azure. I've got this DDD Brisbane. You can see that here, the latest version I have is 16, right? So what I'm hoping is as soon as this finishes, I'll have the version 17 here. Okay, so it will be available for me to deploy to the Kubernetes cluster. Okay, so let's see if that finished. Any questions so far?
That console that's logged in for Kubernetes, how do you make it connect to your cluster?
So you run that get proxy. So when you do the get proxy, you get the credentials, and it caches the credentials locally. And to get the proxy, you have to do at the Azure login, and then you get the proxy. Does that make sense? Cool. All right, so it finished. Here, you can see that the git commit message came, amazing, 2 minutes ago. And I can come here and refresh. It should be right here. So version 17 is out. Now I can deploy that. I could do that automatically, just to configure to also push my change automatically to my Kubernetes cluster. But I didn't do that, so I can show you how the process of deploying works and how the zero downtime deployment works as well. Okay, so I'm just gonna go back here and refresh this page just to see. Oh, it's not gonna be there. So Sydney is awesome. I have to deploy to see if that works. All right, so I'm gonna do a couple of things here. Right. So first, I'm a pretty big fan of command line. So in this side here, I'm gonna do kube control get deployments. So this is gonna list all the deployments I have in my system, in my cluster. So I've got that DDD Brisbane dev, and I've got the PDF that I just deployed. Okay. So here it's going to show the number of instances that is expecting to be running, the number of current instances, and if they are up to date and available. Pretty cool. But one thing that I want to show you, so I can show the actual zero downtime happening and self-healing and all that, is putting this watch here. All right. So what this is going to do is it's going to keep watching for any change that happens, and as soon as there is any change, it's just going to print that. So I'm going to deploy, and we'll see that happening real time. Okay, so I created some deployment scripts that you can go to my GitHub repository and see how the specification for the deployment works, how to create the applications and which image you point and things like that. But instead of showing that, I'm just going to show you how to change the image itself. Okay, so the command will be set image. All right, so my deployment is called DDD Brisbane dev, and the name of the image, the application is DDD Brisbane. And the version, that's a lot to write, isn't it? I'm sure I'm going to miss something here. So I'm just going to go up and show you that. Cool? So I'm just, in this command here, oops, we go up again so it shows that easier. All right, so this command here is just a manual way to update the image. Right, so when you update the image, it's going to start deploying again. All right, so you could do that with the deployment itself, but I'm just showing that just so you can see how manually how it works. All right, so I'm just updating set image to this deployment to this application, and I'm going to version 17 now. Does that make sense so far? Cool. All right, so as soon as I do that, what do you think is going to happen on the left-hand side? Do you think this number is going to go to 0 or 0 here? How do you think it's going to happen? Any guess? No? All right, so let's run it. So when I run that, I'm expecting not to see 0 in the available ever, right? Because we always need to see something available in there. Otherwise, the 0 downtime is not true, okay? So this is what happened. I had 2 instances running, expected, current, up-to-date, and available. At some point, that changed to not being up-to-date anymore. So all of them are outdated. So then it started deploying one by one slowly. So you can see that at some point, we had 3 instances here, which is more than what I expected initially. Right, so it created one on top of it. As soon as it was available, it killed the other one. And it does that one by one until all of them are available and up to date. Is that cool? Does that make sense? Cool. All right, so that was the deployment. Let's try to scale. Okay, let's try some scaling commands here. Okay, so I'm gonna do control scale, and I'm going to do in that deployment. Okay, so what I'm gonna do here is just change the number of replicas. Right, so right now I have 2, and all of a sudden I have more people using my application, and I want to bump it up. Okay, I can do that manually just by doing that. And it's just going to bump the number of replicas, and it's going to start deploying wherever is available in my cluster. You can see that they're becoming available one by one, but the number changed like instantaneously, and it deployed instantaneously. It's just a matter of getting available. Okay, is that cool? Awesome. The same way I can do scale down. So if we can go to 5, it's just going to queue a bunch of instances, and off I go. The same way I can do that manually, I could also do that automatically. I can watch the CPU usage, memory usage, and all this kind of stuff to scale down and up and down automatically. I'm not going to demonstrate that here right now, but you can definitely do it, and it's pretty simple to set up. Okay, what else am I going to try here? So let me try something a bit more interesting. Let's go here to the dashboard. Okay, I can see here in the pods, which are the instances, that I've got a bunch of instances running here, right? So I've got 5 instances of that DDD Brisbane, and what I want to show you here is the self-healing. Okay, what I'm going to do is I'm going to be naughty, and I'm going to come here and say, hey, I want to delete a pod, right? What do you think is going to happen? It's going to go to 4 and that's it? It's over? No? All right, I'm going to delete that. And you see that the numbers changed on the left-hand side straight away, right? So I had 5 instances available, and they went to 4 because I just killed one of them, right? For any reason, like the application just crashed, the node is not available anymore, for any reason. In this case, I just went there being a naughty guy, and it just queued, and it created another one for me. Nice? Okay. All right, so one more thing that I want to show you is, so let me go to the application, the sample application that I just wrote, which is an API with a bunch of endpoints, and that's what I want to show you now. Okay, so you remember in the start of the demo, I deployed that PDF application, and what it does is you send a HTML and you expect a PDF back. That's all it does. Okay, so I created this PDF client here, and what I want to show you is, let me go to the startup. So this client, all I did, that's a very simple client. All I did is pass the endpoint. Okay, so once you have a cluster and you have a service, you actually don't need to change that ever. Okay, so if you, that seems like hard-coded, and it kind of is, but once you have that in a cluster, the service URL is not going to change because it's self-contained, right? So if you have in the service multiple instances of that PDF application, you're always going to hit that as PDF. If you have several environments like production, test, UAT, whatever, integration, you can separate that by namespace, and the URL within that namespace is always going to be the same. So that's how you can separate the environments as well. Okay, but yeah, that's just a simple example. I'm just going to hit that endpoint, PDF, and what I'm expecting is to get a PDF back. I'm expecting to prompt me to download that PDF. Okay, and what I need to see there is hello Sydney. Okay, so I've got my application running here. So if I go now to /PDF, that should prompt me to download. Okay, so that tells me, I don't know why that's so small. So that tells me that the other service is working. Okay, so if I save that, you see that the PDF is now here, and I've got the hello Sydney. They're good. So this way you can have like the whole microservice fallacy that everyone's talking about. So you can have multiple services in your cluster, and you can connect to each other doing this. Okay. All right, so I think that's it for my demo. Let me see if I have missed anything. All right, so I haven't. So I'm gonna go back to my slides here. Okay, but what if you don't want an orchestration? Sometimes you just want to create a single container. So you don't need all the overhead of creating an orchestrator, creating a cluster, deploying, setting up self-scaling and this kind of stuff. You don't need any of that. You can still do it. You're going to lose all the nice things, but you can still do it. You can go to your repository, your registry right now, and you can go there, go to the repository, get the repository you want, get the version you want, and just run the instance, right? So I could show you that right now. I can go there in here, and I can click here and run the instance. And it's going to work very much the same way, but just going to lose all the benefits of having a container cluster, all right? So you just set the name, I can pay as you go, and I can set the port that I'm gonna expose through. It's simple. And I can also set the memory and number of cores and all that. So that's pretty straightforward. Okay, so that's it. All right, so today I showed you how to create a cluster, some of the benefits and what cluster to choose from. And if you don't want an orchestration tool, you can always run an instance only. Okay, thank you very much. Any questions now?
Yeah, I have a question.
Yeah.
So the demo you showed us was about like scaling the application with your Docker container.
Mm-hmm.
How about database side? So how do you scale that database?
So the database, all right, so the question was how to scale the database. So the database is usually going to sit outside the container. I've seen some cases where people would put the database in containers for dev purposes. You can. I wouldn't recommend. Yeah. But one thing that you can do is, instead of having the data in a container, because the container, if the container dies, the data dies with the container, yeah. Right? But what you can do is you can set up a volume in the orchestration, which is an external resource from the container, and having the engine, the database engine, within the container. And then you can scale that up and down. So the engine is going to scale up and down.
Okay.
Does that make sense?
Kind of. Basically, my understanding is that you can, if you want to set up a fresh new dev or staging environment, you can put the database inside. But for production, you
I wouldn't put inside.
Yeah.
I would put outside.
Okay. All right. Cool. I understand.
Any more questions? No?
So if you're scaling by CPU and you've got your VMs, does Kubernetes have the smarts to know where to launch or spawn a container?
So yeah, do I need to repeat the question when they have the mic? Sorry. Yeah, so it is smart enough to watch the resource, because it's always watching the resource. So if we have a look at the dashboard, so let me just go there quickly. Where is it? It's some kind of go to. It's not these nodes. Yeah, so you can see that in here, it's always watching the resource that is that each of the clusters, each of the nodes have available, and it knows that if you have that available, it's going to deploy it there instead of the other node. So it's always watching, and if something changes, so let's say that you have, because when you deploy an application, you set the how many gigs you need for your application. So it uses that, so it allocates that for that instance. So let's say that you have a VM with 8 gig of RAM, and you deploy up to 6 gig, and you have another node with 4 gig available, and you want to deploy something that's going to go over that threshold. Okay. So what's going to do is going to move some pods around so it can fit into the available resources. Does that make sense? So it's going to take the pod from one node to put in the other one, so it enables enough resource to deploy that big application that you want to deploy. So yeah, it is smart enough. Yeah. Cool. Any more questions? Cool. Thank you very much.